Okay, now the next chapter, that is basically the seventh chapter, is differentiation. It's very important. Chapter number 7, that is differentiation. Now, before talking about the course contents and everything, let's just know what exactly differentiation is. Now, when we will talk about questions in this chapter, you would get to see different wordings. Differentiate this, find the derivative, stuff like that. Okay, now what exactly is the derivative or what exactly is the differentiation? Now, we know one thing, that if we talk, and this is something very important because it would be used in the later units of this chapter. So please don't think about it as if it's something extra. Okay. For example, let's say I have this line. Now, if I was asked to find the gradient of this line, I would have picked this point, any 2 points lying on the line randomly, and I would have used this formula m equals y2 minus y1 divided by x2 minus x1, right? So in case of a line, we know that the gradient is same all over the line, the slope is same all over the line. So I can just pick up two random points, find the gradient, and I would know that the gradient at this point, this point, this point, this point, this point, on every point the gradient is same. If the gradient is -2, it's going to be -2 on all the points lying on this line. However, if instead of this line, if I talk about some other thing, let's say if I talk about this parabola, now we know what exactly a parabola is. And what if now I ask you to find the derivative, oh sorry, what if I ask you to find the gradient? So basically, the gradient at this point and the gradient at this point is going to be different. Why? Because if I make a tangent line at this point, I would be able to see that the line is going upwards. And if you guys think about your old knowledge, whenever our line used to be upwards, the gradient used to be positive. However, if I make a line at this point, this line is coming downwards. So this means that my gradient is going to be negative. So this means that gradient at this point and gradient at this point are different. We have two different gradients. So this means that just like the case of line, we cannot find the gradient using a formula and say that gradient all over this curve is going to be same. This is where differentiation is used. So far we know, in case of a line, the gradient, the slope is same. So we have this one formula that we are using every time to find the gradient. But in case of a curve, in case of the graph of a quadratic function, that is a parabola, a cubic function, that is something of this type, or even anything you have that is not straight, that's curve, you know that the gradient is going to be different. Now, if I talk about this curve, the gradient at this point is different, the gradient at this point is different, the gradient at this point is different, it's different, it's different. The gradient is changing with the every next point. Now, this means that we need to use something else in order to find the gradient on all these points. And that is what differentiation does. Okay. Now I'll tell you. Basically, we have a curve. Curve, every line, every sketch has some equation. We would be differentiating that equation. How? I'll talk about that later on. Once you will differentiate that equation, and once we will plug in this x coordinate in that differentiated equation, I am going to get the derivative of this point. Okay, everything would get better once we talk about it later on. So for now, we know the basic idea, right? Anyone has difficulties with the basic idea, that we will again talk about in the future, because there are 2 to 3 proper units on this thing. But any difficulties with the idea behind that, why exactly differentiation is used, or for what exactly it is used?
No, Miss, I think so.
Okay, very good. So now we know that every curve, every sketch has some equation, and we would be differentiating that. Okay, so let's talk about it. Now in AS, differentiation is very simple, but in A2 we would be talking about some more complicated functions, so their differentiation would be more complicated, right? In AS it's very, very basic. Okay, let's talk about the first thing. So for example, you need to differentiate some power functions. Okay, so the very first unit is differentiation of power functions. What does this imply? You'll get to know that shortly. A power function is basically anything of this type. F of x equals x, the power is 1. Or f of x equals x squared, the power is 2. Or f of x equals x squared plus x, the power is 2 and 1. Or let's say f of x is equal to x cubed. So all these functions, all these polynomials, all these algebraic expressions are basically power functions. Okay, now in maths we have a variety. We have exponential functions. If you are not familiar with that, you can just look at a calculator and you would be able to see a small e, right? This is basically an exponential function. Sine, cos, tan are trigonometric functions, right? Then we have a logarithmic function. So we have a variety of functions, and every function is differentiated in a separate way. The differentiation of power functions is the very first thing that we need to understand. Okay, so I have given you an idea about what exactly a power function would look like. So now let's assume that my function is f of x equals x power n. Let's say that this is my function. N could be 1, 2, 3, 400,000, whatever you want, even negative. N can also be negative, right? So n could be any number in maths. And how do we integrate? For now, let's consider n to be a positive integer. I'll tell you why. Acha. How do we differentiate this? So I will write it down this way: d divided by dx. And here I need to either write down f of x, right? This would mean the differentiation of f of x with respect to x, okay? Or instead of this, I can write the function directly which I am differentiating, or I can even write it this way. This is one notation. This is equal to writing it as f dash x, okay? So just pay attention. This d by dx and this dash, both of them are basically used in order to write differentiation or to denote differentiation. The next thing is, what does this x implies? Now for now, you guys can see that in your function, the only variable is x. But let's say if you come across something of this type, x plus y squared, you will get to see such functions as well in future, right? Once you go to A2. So at that time, you will understand that we need to be very, very specific about the variable with respect to which we are differentiating. Okay. So in AS, we would be talking about one variable only. That could be X, that could be T, it could be Z. It would depend upon the examiner, whatever variable we have. And this is how it is. Okay. And how do we write it down? So The differentiation of x power n with respect to x is whatever you have as power comes over here, and the power would be subtracted by 1. So this is the very first formula which you need to keep in your mind. Yes. Any confusions with this, with the formula?
No, miss.
Okay. And let me write it down here clearly. One second. F of x was equal to x power n, and as I've said earlier as well, n is a real number. Now, what is a real number? A real number is any number in maths. It could be a positive number, it could be a negative number, it could be a decimal number, it could be a fraction number. Whatever number you have on your number line, we have 0, we have 1, we have 1.1, we have 2, we have 10, we have -1, we have -100. Whatever number you have on your number line, that is basically a real number. So n could be any number, and you would get to understand this concept within a few examples. Okay, so let's talk about 1 to 2 examples, because I am not going to pass paper questions directly. Let's say that we have example number 1, and the question says find the derivative of, and part A says f of x is equal to root x, and part B says y is equal to 2. Okay, now I've just used the two most unique examples from the book. Acha, for the first part, the question says find derivative. So now we know derivative, differentiation, gradient, slope, all these things are exactly the same. Differentiation is going to give you the slope or derivative for a curve. And even if you differentiate the equation of a line, you are going to get the derivative or the slope or the gradient of that line, which you were basically calculating through that formula y2 minus y1 divided by x2 minus x1. Okay, so in order to write it, I can write it down this way. The differentiation of root x with respect to x is basically equal to, now at this point, I know that root x is basically equal to x power 1 by 2. So I know that this power would come at this point. This power is going to come here. So 1 by 2 into x, and in the power of x, I will do old power minus 1. So this would give me 1 by 2 x power minus 1 by 2. This could be the answer, but in order to write it down more properly, I will write it down this way. 1 divided by 2 into root x. This is going to be the answer. Yes. Any difficulties with this?
Miss, how do you say that d and root of x divided by dx?
Yes,
Like the proper way.
I'll tell you. It's basically the differentiation of root x with respect to x. Let me write it down here. Differentiation of root x is our function with respect to x. And I've told you the logic behind this dx in the denominator. So basically, in the future, you will get to see more variables in one equation. And then you will be like this, that okay, we are subtracting 1 from the power, we are writing the power as coefficient, but for which variable? With respect to which variable? Let's say you have something of this type, y equals x plus t squared. Now, when you will start differentiating this, you would certainly get confused that yes, I know I need to write this power uh, as coefficient. I need to subtract 1 from the power, but for which variable? Am I supposed to do it for x or for t, right? So for that point, we are specifically mentioning that you need to do it with respect to x, with respect to the independent variable. But for now, just know it is x. And that in case of as, you would be only having one variable at a time, okay, in your equation. So any difficulties with this?
Miss, you wrote f of x in the
Yes.
question. So why
Yes.
didn't you write f prime and x?
Yes, I'll tell you. But this is basically f of x equals root x. F of x equals root x is the equation. It is the function that I need to differentiate. I can certainly write down f prime x over here, okay? Because this means the differentiation of f of x. This means the differentiation of something that is equal to f of x. So these two are equal. These two are same. Mathematically, they mean the same. But in the question, obviously, I would have f of x equals root x. The examiner is going to give me the actual equation, the actual function, and then I will differentiate it. So this means the differentiation of f of x, okay? And this is only the equation of f of x.
Okay, miss.
Okay, very good. Acha, now he can give you the expression directly as root x, 1 by x, x squared. He can give you as f of x equals to something, or he can also give you as y equals something, right? All of them would be same. You would get used to this concept in even by the end of this class, so just don't worry. This time around, we have y equals to as the equation, and you need to differentiate it. Now, first of all, I know that I can write it as d by dx. And here, since I have 2, I can also write it down this way as well. I can also write it down this way as well. Mathematically, that is certainly correct. But a good way of writing it down is dy by dx, because you will see shortly every equation would be starting by y equals x squared or y equals root x. So there, this is the most used notation for the differentiation, right? Dy by dx. And even here, I could have written it this way: d of f of x divided by dx, right? So all of them are correct. This thing is equal to this thing. And dy by dx is equal to d brackets 2 divided by x. That is also same, okay? But don't worry about the notation. This thing would get better in some time. Just forget it for now. Acha. Now this is equal to. Now I need to differentiate y with respect to x, but I cannot see any x in the equation. Where is my x? I do not have any x. So at this point, I need to assume that I have an x that has power 0, because I know anything to the power 0 is 1. So I can certainly multiply 2 with something that is equivalent to 1. So whenever you have some constant, just know that it has x to the power 0. Now, this power is basically multiplied here. So this would become 0. So if you have any constant, any number, that is always going to give you the derivative as 0. Is this thing clear or not?
Miss, we could have just directly done that. The power of 2 is 1, and when we will bring it and multiply, the power of 2 will be 1 minus 1. So
No, no,
the
no, no,
final.
no. No, you cannot do that. I'll tell you why. That is a very good point. I'll tell you why. You cannot do this because here we are doing with respect to x, okay? You need to play with the power of x only with the power of x. not with the power of number. It has to be for the variable's power only, not for the number. Okay, always remember this.
Okay, Miss Gauri.
Okay, that is why we are writing it down as this. Okay, acha. Let's talk about two more examples this time
Miss,
around.
Miss, we could have done that x to the power of 0 is equal to 1, right?
Yes,
So,
yes.
2 into 1 to the power of, okay, then it will be becoming, okay, Miss Gauri.
Yes, yes, yes. Again, that would basically be a number. So the fact that I can multiply anything with 1, it made me write down x power 0. But in the questions, you will see once we are done with a few cases, I'll just write down some cases that whenever it is a constant, derivative is 0. You're not supposed to do it this way. Like you can certainly do it this way in the exam, but no need to, because this is not going to be, these are not going to be the questions. I'll tell you the how the questions are going to be. Let's talk about one question. That is basically the third question. This time around, you have been asked to differentiate y equals x cubed plus x squared. Now, this is your question. Again, you need to differentiate. Now, first of all, we'll think about the notation. How do we write differentiation? So, I've told you we have several ways. You can write y prime just like we wrote f prime, or you can write it as dy by dx, or you can write it as d of whatever y was equal to x cubed plus x squared with respect to dx. Okay, so all these ways, all these notations are equivalent, and this is d, I'm sorry, and this is the best one. Dy by dx is the best one, and you will get to see this time and again in your books, and I'll be writing it down this way. Okay, so dy by dx, but all of them are equivalent, all of them are same. But now we will make this a practice, that whatever our expression is equal to, we would be writing that thing over here. Although this is also correct and this is also correct, but basically instead of writing down y dash, we would be usually writing down f prime of x. Although all of them are correct, but this is how it is in the books, right? So for this, let it be like this, and now I'll do the working over here at this point. Okay, now, so let's talk about the solution. So I've been asked to differentiate y equals x cubed plus x squared, and I can write it as dy divided by dx equals, now I need to differentiate. Now what would happen? It's very, very simple. Both of you know that we have 2x. We will deal both of x separately. So the first one is this one. The power is 3. This power is basically gonna come here. It's 3x. The old power is 3. Very good. The old power is 3. We will do minus 1 plus. This is a separate case. I have 2 here. This 2 is going to come over here. Plus 2 into x. And in the power of x, I'll write it as 2 minus 1. This would basically become, let me write it down. The next line, this would become 3x squared plus 2x, and this is going to be your answer. So now what do you know? You know that if you have been asked to differentiate something and that something has basically multiple expressions within one equation, we will deal with all those expressions separately. Okay?
Okay, Miss.
All right. Let's talk about another question. Acha. This time around, again, you need to differentiate y equals 3x to the power 4 minus 1 divided by 2x squared plus 4 divided by root x plus 5 with respect to x. Okay, so this thing is mentioned. Let me write it down properly. What is happening? Okay. So this is the fourth question, and again you need to differentiate this thing with respect to x. Now, let's talk about the solution. First of all, let's talk about the notation. Now we know that it's y equals something, so I can write it as dy and not dy divided by dx, we'll write it as dy by dx. That basically means differentiation of y with respect to x. And what is y? This entire thing is my y. Okay. Now, how do we do it? I'll tell you. Now, this is very, very complicated, but we will do an extra step in order to simplify it. How? First of all, I'll write it down in the next step. First of all, I need to have all the x's in the numerator, and I would want that all their powers should be mentioned numerically. For example, here I have root x. Instead of having root x, I'll write it as x power 1 by 2. So I'll take this x squared from the denominator to numerator. Mathematically, that is possible. How? I'll write it as y equals 3 x to the power 4 would come as it is, minus 1 divided by 2 would come as it is. When I will take this x squared from denominator to numerator, what would happen? This would become x power
minus.
minus 2. Very good. Then I have plus 4, and this basically is x to the power 1 by 2. When I will take this x to the power 1 by 2 from denominator to numerator, it would become x to the power negative 1 by 2. Very good. Plus 5. Okay. So I have written the equation again, just so all the variable, that is all the x's I have in the equation, are in the numerator and their powers are mentioned specifically. Now we can differentiate. Dy by dx, this is the notation of differentiation. This number is going to come as it is, and this 4 is going to be multiplied over here, and we have 4 as old power, so I'll do minus 1. Then this minus would come as it is, this 1 by 2 would come as it is, and now this negative 2 would be multiplied over here. So I'll write negative 2 here, it's being multiplied, and x has the power negative 2, and what do we do with the power? We do minus 1. Old power minus 1. Old power is minus 2. The power in equation is minus 2. In the derivative, it would be old power minus 2. Again, plus 4 would come as it is. This is negative 1 by 2. This negative 1 by 2 is going to come here. So I'll multiply that by negative 1 by 2. X would come as it is. The power is minus 1 by 2. Old power minus 1. And now for this 5, now we are mature. No need to write it down this way and then do your step. Whenever you have some constant, just know that the derivative of that constant is going to be 0. So that is your rule. Let me write it down here. Okay. Now what has happened? Why is this question comparatively difficult? Because in one equation, We have 4 expressions. We have differentiated all these 4 expressions separately. In the beginning, in the equation, our variable, some of the variables were basically in the denominator. We need to make sure that everything is in the numerator. Why? Because the rule that we have studied basically had x to the power n. So x to the power n means that your variable is in the numerator, and n could be a negative number, so that is fine. But all you need to do is just take your variable from the denominator to the numerator. Now, for this one, this was the differentiation. The number 3 came as it is. Then 1 by 2 came as it is. This 4 came as it is. I have not done anything to these numbers. Okay. And then I've done my differentiation. So let me just simplify this further. This would become 12x cubed minus and minus 2 and 2 would be cancelled. And this is going to give me positive x to the power negative 3. Then positive and negative would make it negative, and 2 and 4 would be cancelled, and this would give you negative 2, and we would have, one second, negative 2 x to the power negative 3 divided by 2. Okay, so let me simplify further. Although this can certainly be your answer, that's fine, but still it would be 12x cubed. I'll take this to the denominator. It would become 1 divided by the cube root of x minus 2 divided by, it is x power 3 by 2. So do you guys know that I can write x power 3 by 2 as the square root of x cubed? Are you familiar with
Yes.
this
Um,
concept?
Yes,
Yes?
ma'am.
how did x to the power of minus 3 become uh, uh, that thing?
Yes. You're right. You're right. Very good. Thank you. Thank you. Thank you. Yes, certainly. It's not minus 1 by 3. Very well done. Yes, it's x cubed. It is x cubed. Yes. This is correct. Okay. Okay. Are you familiar with this? That x to the power 3 by 2 can be written this way?
Yes,
Yes,
ma'am.
miss.
Okay, perfect. So I can finally write this part as the square root of x cubed. So this is your final answer. Although the answer before the step was can also be considered as answer, right? Like this step can also be considered as your answer because mathematically that is fine. And that is it. This question, you can think about this question as a past paper question. We'll do past paper questions tomorrow. Not tomorrow, obviously, in the next class. But you will get to see that the difficulty level is exactly the same like this one. Okay. So in AS, differentiation is very, very easy. Yes, in A2, it becomes difficult. I would agree with that. So what do we know? In case of differentiation, if we have one equation with different expressions, we are going to deal with that differently, separately. If we have x to the power n, n would become the coefficient and we would do n minus 1 as the power of x. If we have any number written next to x, nothing is going to happen. That number has to be written as it is, except if the number is coming separately. If you only have one number, then here is your rule. If it's only one number, if it's only a constant, the derivative of that is going to be 0. So these were some rules that we had to discuss. Let me talk about one last question that would help you with the understanding. This time around, the question says, no, we'll do it in the next class because this one is a bit more different. We'll talk about it later on. Okay. Acha, वैसे, are you guys familiar with tangents?
Yes, miss.
Okay. So at least we know that if this is a curve, the gradient at this point is basically equal to the gradient of the tangent at this point, right? This is not tangent. Let me make something simple. Okay, this is a curve. Let's say this is a point. Now the gradient at this point is basically equal to the gradient of this tangent line. Okay, so the gradient of tangent is equal to the gradient slash slope slash derivative of the pink point. This is very, very important. We will be using this concept in the next class. So we know that if we have a random point like this, and if I don't know what exactly its gradient is because it's a curve, I am going to make a line at this point. And this line is basically a tangent to the curve. The gradient of this yellow line is same as the gradient of the curve at this red point. Okay. The gradient of line is not line, the gradient of tangent is equal to the gradient of the curve at red point. Okay, so I have just added these two descriptions as well, just so we are able to understand the concept. And point is gone. Okay, yeah, that's fine. Yes, is it okay? Any confusions with this?
No, miss.
Munja, what about you?
Okay, miss.
All right, okay. Because we have already discussed this in the last session with you, right?
Yeah, that's true.
Okay, perfect. If we stop the recording.